working area, that is the research room on the first floor. On the first floor, there are 2 bedrooms and the working area. The roof we design is a vault, which is self-supporting form. The material of the vault is ferrocement with interiors having the clay conical blocks, which will help in maintaining the thermal comfort. The elevation shows the overhangs of every windows. There are winders placed on the western side of the building, which can be controlled by the users whenever they need. The winders are made up of jute material. The exploded axonometric view is being shown where different materials palettes have been displayed. It is the exploded view shows different spaces which could be easily seen. The living area is double height, has a double height, and on the southern side there are external staircase placed with bamboo as the railings. On the left are the details mentioned. Pillar slabs can be used on circulation areas.
So moving forward to the market potential of the structure. So as mentioned earlier, Neil Parna will help resolve the issue of settlements along the coastline of India. In next 50 years, that are going to be affected due to rise in sea levels. Neil Parna is a modular design solution to sustain the climate change and its adverse effects. The use of locally available materials helped us reduce the construction cost of the net zero structure by around 12% than the standard RCC construction. The innovative technologies like use of jute winders with timber framing to reduce the absorption of solar radiation, the rain gardens used to reduce the flood water accumulating in the site, the green roof used to reduce the thermal shock due to the direct heat received on the south side, are some of the strategies which can also be implemented to the other site in the same area as well. This will help the community as a whole to face and survive the problem of destruction due to flooding. Our vision with this project is to make communities as a whole to face and survive the problem of destruction due to flooding. So this was a team effort from Team Dharatatva and under the guidance of faculty lead architect Madhura Rasne ma'am and faculty advisor architect Sanika Kulkarni ma'am. We would like to thank our project partner, AERF, industry partners, Sahyadri Industries Limited, and Solar Decathlon India for giving us this opportunity. Thank you.
Thank you, team. You finished well in time. Let's hear the jury comments and take questions from them.
Thank you, team. Excellent presentation on various parameters. So you moved from the local available material to concrete structures. And also the salinity in the soil, it is there. So what kind of materials in concrete, in terms of cement, you have used? Because sustainability comes from cement also. The cement is the most carbon emitting product. So what cement you have used? There's no mention of the type of cement you have used, type of technology you have used in concrete making.
So we have used normal Portland cement with admixtures which help us reduce the carbon.
Which admixture?
So I don't remember the name.
Okay. I know you have not gone through it properly. Okay. Generally, we can use the blended cements or GGBS or fly ash. It will reduce almost by 50% the carbon footprint in concrete making. So overall, I found it presented very well for that environment. The emphasis on like how to make net zero, the practical approach is very important rather than theoretical approach. So I think we'll take it forward in the next buildings what you design. The practical approach and the material science also is very important. That's what I wanted to say overall. Thank you.
Good job, teams.
Thank you, ma'am.
Good effort. I like that you explored a lot of passive design strategies with the jalis, the vaulted roof, which works well in a humid kind of climate, aids ventilation. You looked at courtyards. All of that is really good. Coming to, I thought that you could have seen a lot of advantage of these strategies that you've explored in how it has reduced embodied energy overall, which probably you could explore more. We didn't see much on it, but it's an opportunity for you to look at, yeah? Coming to the evidence side of it, you showed some calculations on lighting and some basic ways of how you've come up with the final energy numbers. I was not sure, have you used like whole building energy simulations to come up with that? Or how was the calculations done?
So the calculations were done on the basis of the appliances and the LEDs and luminaires which we had used in the building. We could not find out the whole simulation by the software as such, because we were short with the material which we actually have explored it, and we couldn't find the results which actually were to be given.
So that is something I'd recommend that you explore that, because that's a very important piece of providing evidence of how the passive strategies that you've thought of is actually working to save energy and also to provide thermal comfort. I would have liked to see some evidence on the comfort part also. On one of the slides you've shown the temperatures are 24 to 29. It's pretty comfortable. I'm not sure if it goes on the higher side. I think it's pretty likely to go up to 33, 35. But you want to put more emphasis on the evidence part, right? Thumb rule calculation is okay, but those simulations will give you a more realistic understanding of what's happening in the building. Right. So yeah, that's my comment.
Yeah, good job, team.
Sure.
I agree with Deepa that you needed to do few more simulation studies. You need to quantify how much you are saving through your design. Otherwise, it becomes only architectural design. It has no technological background. And that is what this competition is all about. Na? So, thoda quantify karna padega aapko. You are which year students?
Third year.
For third year, you've done a really good job. So congratulations.
Thank you, sir.
Right. Just a few comments. You have to explain the slides. Right, all of you are just going through your material, but you are not explaining the slide. What's happening in the slide? So like one of you showed with the pointer, probably you should use that. वो करना है. One place you mentioned that you have used high U values in your materials or for your roof and walls and all. But it's not high U values, it is, you are looking at low U values. Lower the U value, better, as a thumb rule.
Yes.
But when you do the simulation, you might find that high U values are also good. That's why you need to do that. In your renewable energy calculations, you've shown that you are producing or generating more than you are consuming, right? So you have to emphasize that. Then it becomes a zero energy building, na?
Yes.
वो करना है. Similarly, even for your water calculations, you are having more rainwater, harvesting more rainwater than you are consuming. So again, it becomes zero water, right? Or no? Water positive. So you have to again mention that. Emphasize the good things that you are doing, right? And then resilience was well presented. In CEC blocks, you said you used the CB block to reduce the humidity, right? Again, you have to say, okay, humidity reduce hota hai, to how much? 5%, 10%, 20%, right? So you have to always try to quantify with numbers.
So actually the problem with that was we couldn't find the softwares which had these materials.
Yes, that is a good,
yeah.
good
So-
answer. But probably you could have looked at case studies, and they sometimes mention. So case studies you can refer to. That
Yes.
some building here has reduced so much. ठीक है. The applications part was good, or the app that you have prepared is good. And architectural design, I think you have excelled in that. Very, very good.
Thank you, sir.
You have integrated everything together. Regarding the foundation detail, probably you are a little bit weak in that, so you try to improve that. Or if you want to explain, you can explain again. So otherwise, a good job done. Third year students, you attempted a big, big project and you have actually succeeded. So
Thank
wish
you,
you all
sir.
the best. Okay.
Thank you, sir.
Thank you, jury members, and thank you, Team Dhara Tatva. Let's take 5 minutes and get ready for the next presentation. Our second presentation is from Team Sugriya. They have worked on a luxurious net zero energy single family housing in Jaipur, Rajasthan. Their project partner is Mahima Group. Just give me a minute. Jury. At 15 minutes, I will ring a signal like this. Abraham, I request you. Yeah, thank you. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentation. After that, we will have 10 minutes for a Q&A session. Please keep your answers direct and to the point. Okay, team, the stage is yours. All the best. Your time starts now.
So, a very good morning to one and all present here. So, a very good morning to one and all present here. I, Utkarsh, Arshdeep, Prakash, and Rajnish, on the behalf of Team Sugriha, are going to present a net zero single family house. Okay, so aimed at creating a sustainable lifestyle without compromising luxury, our project partner Mahima Group identified a specific niche segment of the society who wants to get out of hustle and bustle of the city and wants a luxurious lifestyle. So, our project located in the composite climate of Rajasthan, in the outskirts of Jaipur city, mainly focused on nuclear family of around 4 to 6 members in the Mahima wind chimes. So, with these special requirements, we were required to provide pool, open spaces, landscaping, restricting ourselves amongst these bylaws. We analyzed the strengths, weaknesses, opportunities, and threats of our design and designed accordingly, considering the opportunities like expanding our site to the adjacent plots, weaknesses like scarcity of water and unavailability of municipal services, threats like hazardous chemicals secreted from the industries nearby, and threats from the animals. We did a climate analysis for sun-path diagram, wind. We identified the comfort band and diurnal variation, which helped us to identify the strategies for thermal mass design, sun shading, active and passive strategies. We worked up our design upon these 10 contests and analyzed the performance based on each of these. As shown over here, this is the interior layout of a house. Going around it, the terrace garden, the stepped pool around it, dining area, kitchen garden, parking. So coming to the architectural design, we identified our target customer, their activities, and identified the spaces accordingly. Converting those spaces into massing, staggering it, and merging it with the landscaping, water bodies, and microclimate. We zoned out the spaces as per their functionality, arranged them as per requirement of our project partner, did multiple iterations to make them functional, and ended up with this site plan, which totally harmonizes with the surrounding. And here we have an opportunity to expand it towards north and south in case our client wants to expand their building. So we have a total possibility of expanding this segment. We did a special emphasis on passive strategies, like as shown over here. The evaporative cooling works very well through this small water body. The cool air rises and it flows through our entire building, and hot air escapes out from the exhaust in the multi area. Considering all the passive strategies, we have designed a plan very strategically with a good airflow, cross airflow, and natural ventilation. Our building harmonizes very well with the surrounding and nature. As shown here, elevation merges very well. We have boundary wall made out of rammed earth, building made out of CSEB blocks, and landscaping provide a good shading all around with sensory gardens, stepped pools, which also acts as a rainwater harvesting tank in case of excess rainfall. Sections, as shown here, we have been providing ample light through clear story windows, cantilevered portions, and all those architectural elements. Coming to
So now coming to the energy performance, we see that we had the baseline of 52 EPI, which consisted of 3-star rated equipments and solely based ACs. So adopting the energy conservation measures, we were able to obtain the 31.62 EPI. That is like we adopted some schedulings. So accordingly, through the software, we were able to obtain 61.2 EPI. So during this WWR simulations, the daylighting simulations, the WWR was optimized in such that we were able to obtain the LPD reduction of 62% from 5 to 1.9. So these are the daylight simulations you can see. And this is something important for a human well-being also, because the circadian regulation also happens through the daylight. So now looking upon the climate data, we saw in summer months, there is a wet difference of 14 degrees. The wet bulb depression is approximately 13 to 14 degrees. So through the CFD simulation, we inculcated the evaporative cooling into the living spaces, and we could find that the person was able to obtain the thermal comfort. Through radiation analysis, we saw that we oriented the building in such a way that there is least solar heat gain, and also the shading analysis was done. Now coming on to the renewable generation part, we have solar as well as biomass with us. These solar panels, even after their life end, they will be providing us the good energy. In a way, we are energy positive. So through this graph also you can see the generation is more than consumption. So we are energy positive. Adding on to this, we are also aiming to be near zero on site, on the source. Like on the source, there are transmission and distribution losses are there. So in that case, we are also targeting to be near zero on source. So now coming on to the water.
So now coming on to the water. As we know, Jaipur has low rainfall as compared to other cities in the country. So we have used efficient harvested rainwater system so as to collect a good amount of rainfall. We have used harvested rainwater, recycled grey water, and groundwater as our viable water source. Hence, we are self-reliant based on water. We have used different water reduction fixtures so as to reduce our per capita demand from 135 liter to 75 liters. Now moving on to water cycle diagram. Here we have used harvested rainwater as our primary source, and groundwater will be used in immediate or extra water uses. Here the harvested rainwater will be used for different usage, and the grey water generated will be used in the flushing, and the extra grey water will be sent to the water treatment, wetland water systems, and the black water generated from the flushing will also be sent to the STP, where the solid waste will be separated from it, and the solid waste will be sent to the biogas plant. And the outlet from both these grey water and the black water separated water, these will be used in the outdoor and indoor landscaping. We have 4 occupants with 75 liters, 75 LPCD. And for irrigation, we are using drip irrigation and xeriscaping, which will reduce our irrigation demand to 20%. We have used 1.3 liters per day per meter square as our irrigation, which is for 170 meter square area, that is 221 liters per day. Here we have shown the division of rainwater harvesting tank, that is in underground 60,000 liter, rooftop storage as 10,000 liter, and stepped pool as 15,000 liter. Actually, we have used stepped pool in rainy season as an extra storage, like it is a multi-purpose pool. Here we have shown the end uses. Here for the waste management system, we have used wetland system in the 3 stages, which have good removal efficiencies up to 95%. And for the solid waste management, we have used Deen Bandhu biogas plant of capacity 1 meter cube per day. Here let's see our house with different materials. And in the wall envelope, we have used CSEB blocks. That is 2 CSEB blocks in between, air is also filled for the insulation. Here you can see our wall envelope and roof envelopes. As I have said, that we have used 2 CSEB blocks in which air cavity of 60 mm is there. And in the this slab part, we have used this RCC slab of 125 mm, that is with 25% GGBFS. And also for the low U value, we have used vitrified glazed cool roof tiles. Here we have also compared different carbon values of different materials of baseline and proposed. We showed that our proposed value is very much less than the baseline. Here you can see in the graphs. Here, we have, in the graph, you can see that we are able to reduce our total carbon emissions per functional unit by 83.6% from the baseline, which is also represented in the tables. Here, we are able to reduce our transport emissions to 2% by using locally sourced and vernacular materials. Here, the carbon emission per kg material is also shown.
Now coming on to the resilience part, you can already see this potential risk have been mapped along with the solutions. So here the key takeaway we want to convey is like there is a biogas plant at our site along with the kitchen garden. So that ensures food self-sufficiency. Also, we have provided a battery backup in the form of lithium-ion batteries, which will suffice for 5 days for the whole building. So we have the storage, as Prakash mentioned, that there is 85,000 liters we can store. So that gives us the water autonomy of 7 months for our site. Now talking about the passive performance of our building, through that psychometric chart, we were able to find that for our building, the comfort hours without any active usage are 246 days.
Moving on to the engineering and operations part, we have used renewable energy sources for completely independent of using the So for being not relying on conventional energy sources that we are having. So incorporating that, next slide please. Yeah. Looking at to the electrical layout of our house, which will help in automizing our smart home. We have designed a app for proper managing of electrical appliances and for proper optimization and for reducing for increasing our efficiency of electricity. Next. Yeah.
Now, as we have discussed on the technical aspects of our building, like energy, water, carbon, and materials, let's deep down into the long-term aspects of our building and let's classify its impact.
Now talking about value proposition, we offer different features for our customer. That is, one of them is that we offer customization to our customer. That is to make them feel that it is their own home. And we achieve this by providing the experience of VR model in collaboration with our industry partner, Plan M. Now we have also made public awareness about our project in college by taking offline sessions with the students. And also we have talked about our project with many industry experts. You can also see in the photos.
Yeah, moving on to the innovations part. As the first part of our innovation, as we know, due to the harsh heat in Jaipur, the efficiency of our solar panels decreases by 20 to 50%. So to tackle that problem, we have incorporated automatic water sprinklers to our panels, which helps in cooling our panels and hence increasing in efficiency of our panels. Moving on to the second part of our innovation, we have incorporated step-type dynamic pool as the part of luxury segment part of our project, as a part of requirement of our project owner. So, yeah, step-type pool helps in different ways by creating a cool microclimate around. By working as a RWH tank during rainy season. It also incorporates with retraceable shading over the pool to reduce the evaporative losses.
Okay, now moving on to affordability. Now we have compared the baseline and proposed of our life cycle cost of the project Here you can see in the pie charts that we have reduced our OPEX from OPEX component from 48% to 14%. Here you can also see the cost components of various components of components of the cost. Here, in the graph you can see that we have reduced our total life cycle cost from the baseline cost by 12.74%, which is represented in the table as well.
So since we all know COVID has taught us, reinforced that the health is the primary thing. So incorporating the health and well-being into our own living spaces is very critical. So these are the pointers which we have adapted. These are the latest technologies which exist in the market. So ensuring that thermal comfort, the healthy air and everything, that security is also included. So this is something what we propose, like the biophilic design of our building, which includes the terrace and sensory gardens. This, the nature itself is a stress buster. So that will ensure the physical and mental well-being of our clients. Yeah.
Now let's look upon what we have achieved so far. In terms of energy, we have been able to net zero positive. In water, we are very good. Reduced embodied carbon by more than 80%, reduced solid waste by 80%, while ensuring the privacy, security, and achieving the LCC reduction of more than 12%. This shows our process, how we worked throughout the 9 months of this contest, using these softwares, the process of team, their functioning, and various meetings. This is our team Sugriha, who has worked for this, and thanks a lot.
Thank you, team. You gave a very insightful presentation. Let's hear the jury comments and take questions from them.
Excellent presentation and all the aspects. The summary was very good, like how we have done the overall. So I wanted to have the comparison, like the baseline, total baseline, and how much you're totally reduced, say net zero, moving towards net zero balancing. So that was missing, the comparison chart between the traditional building and the net zero building. Okay. Otherwise, your presentation was good, well presented, and your team has put a lot of efforts in working on this thing. So Jaipur, my question was, I am from the building material science. The GGBS you mentioned, so where did you get GGBS?
Yes, sir.
You mentioned you use GGBS?
Yes, sir, we are using 25% GGBFS and 75% Portland cement to reduce carbon.
Okay. Yes. This is for which product? You manufacture some panels, right? For that or for the entire concrete?
Yeah, for entire concrete we are using 25% GGBFS.
Where did you get the GGBS?
Well, it will be taken from the store nearby. Well,
it's not available.
Yes.
It's not available. GGBS you can go up to 70%, not 5%. Minimum usage of GGBS as per IS code is 25%.
Yes, sir, we have used.
It's a cement replacement.
Yes.
Since you mentioned, I'm asking that question.
Okay.
It's not available in stores everywhere.
Yes, yes.
Only available in south and western part of India, not in Jaipur. That product is not available.
Yes.
So you be careful when you are mentioning some product name. Okay.
We are not sure about where to buy, but we sure are using in our project.
The usage of GGBS, the carbon footprint of GGBS is 60 kg per ton.
Yeah.
Cement is 800 kg per ton.
Yes.
So if you use, you can go up to 70% replacement.
Yes.
Okay. Yes. So GCBS usage is to be increased up to at least 50% average. Okay.
Okay.
So be aware of that. If you require the product, I will be able to provide for you. Okay.
Sure, sir.
Excellent, excellent presentation. Very nice. Okay. You mentioned available product and all. Yes, so you should deep dive into the product. What is the replacement levels? Okay.
Sure, sir.
Overall, your presentation very good. Thank you very much.
Thank you. Ground granulated blast furnace slag. It's actually when iron burns, is the slag which represents it reduces carbon emissions. Actually.
I have the brochure also to give it to all of you. Okay. It's a product which JSW manufactures. We are global leader in product manufacturing. We have reduced 9 million metric ton of carbon dioxide in 6 years using this product.
Yes.
All the metros, highways, projects are using cement replacement, Portland cement replacement, saving both calcium, silica, and alumina. Equivalent to less than cement, little bit. It's a steel industry byproduct, which is now gaining acceptance. It's a blast furnace slag, which we ground into fine powder. It's very whitish in nature. You may be knowing the fly ash. It comes from a thermal plant. The fly ash can go up to 35% maximum. This product can go up to 70% replacing cement. Yeah, it's a very good product. In South India, all the RMC plants, projects they are using. The road which we came on Bangalore-Mysore Expressway, they have used 2.5 lakh tons of GGBS, reducing the carbon footprint of 2.5 lakh tons, almost 2.4, and 2 lakh 30,000 trees they have saved by using the product. That road you came from your, and Bangalore Airport Terminal 2 has been built with completely GGBS. They have saved almost about 1 lakh tons of carbon dioxide.
That's nice.
Okay. This product is very accepted here. I'm not marketing my product, okay?
Understood.
Yes, of course. Okay, great energy, guys, the way you started off. So kudos to you. I like that you were not reading and you were speaking, and that takes a lot of effort, so very good job. Of course, it could be better, but I think that's a good effort and the stand that you took about that. I like the flow. You first talked about architecture design, and then you went into all the details, which gives a good understanding. So there is a sequence to it, right? And you also explored all contest areas in good level of detail, I must say. It takes a lot of effort to do that, and you've done a great job in all of the contests. Of course, there can be a lot of questions, but in the interest of time, I would like to ask about, this time I was curious, you had this wall section, you said you have SRI paint. Is it on the walls?
Yes.
Or was that for the roof? For the roof?
And very few parts of the exposed wall.
Because all your renderings show like you have exposed CSEB. Is that how you have? But you have plaster also, right? Could you explain the wall section once more?
Lime plaster, and at very few locations we have high SRI paints as well. Maybe southern and
On the wall.
on the-
What made you think about using SRI paint on the wall? Typically, it's used for the roof.
It was used in a particular case where, in this especially southwest corner, near the wetland part and composter part.
Wetland park?
Wetland and composter,
Yeah, so what made you use it? The
like to
paint?
reflect the heat.
Okay. So is that working well in your simulations as you may have seen?
Not a significant difference.
Something to
Just
think
little.
about. Okay. The other question I had is, you've shown evaporative cooling, but in the end you also showed there is split ACs. It didn't come across in the beginning, and then in the end you talked about health and well-being and all of that. And then you showed how you are achieving good thermal comfort by using evaporative cooling. And I saw in the electrical diagram it's kept in the living room near that wall abutting the pool, right? Now you have all of this going on, and I believe evaporative cooling will be seasonal kind of use,
Yes, ma'am.
right? And the other times you have the split AC, but you also have this whole jali and the whole ventilation thing going on. Did you look at and then you also said there's automation in the windows. In the end, is it really thought through, or is something that you think that it's a good to have thing in the building?
Ma'am, basically that sensor-based control for the windows was thought in because it could help in the infiltration issues, which generally occur like the hot wind when it comes into the room. It's impediment to the thermal comfort of the people. So And talking about, yeah, it's seasonal. So like for the summer months only, we have incorporated. Basically, it's natural as well as the forced evaporative cooling that we have incorporated through the pool and through the device.
So for evaporative cooling, you should actually keep everything open. That's when it works the best. So, you may want to see how you've taken into account all of this into the simulations and then arrived at that number. Okay, I'm not too convinced about that.
Ma'am, regarding that natural evaporative cooling, that was not, we were not able to do in the simulation part. I could put in the cooler, through that I could simulate, but not through, the natural part was not into the simulation part.
So these things are to be considered when you arrive at the overall energy, because you're looking at life cycle cost. This all ties in. So it's not necessary that it has to be through simulation and one program. You can find other ways to do the calculations. And so what you showed was not too convincing, but I understand your thought process and your idea that you were trying to explore. And I'm also not convinced about the swimming pool being used for, of course it'll get filled in rain, but you've added it into your calculations also as a storage. It's not very convincing.
Actually, the swimming pool will be used only, it is a multi-purpose pool. For summers, it will be used for around 3 months as a pool. In winters, it will be used as a get-together point, like a bonfire and all. And for the rainy season, it will be used as an extra storage of 15,000 liters.
So you're going to pump the water through the house because it's a rainwater storage tank?
Right, we'll do that.
Yeah, so that needs to be thought through, okay? That's why I'm saying it was not convincing. Yeah, so those are the...
Yes.
Okay, good job.
Thank you.
Students. You have got very good illustrations, drawings, well done. Even your 3D animations you showed, very, very well done. That means you completed your design. You also looked at the technologies, and you summarized everything like Sir said. So you've concluded also. So overall, a good job.
Thank you, sir.
One comment is that sometimes you have a tendency to, rush through the slides. So explain the slides. It's okay.
Time constraints.
Time constraints, I understand. But then showing a slide and people not understanding is also not too good.
Yes, I agree.
Thoda time lo, dekho. Not running a relay. Okay. Good job of doing the simulation for daylighting and comfort. Through evaporative cooling also you did, no?
Yes.
Yeah, good. So you attempted simulation, very good. Comfort hours, you say 246 hours, no, days, right? You've been able to achieve, but that was through the psychrometric chart only, right? Okay, fine. And carbon emissions reduction of 80%, 86% is commendable. 86, oh, 83.6. Very good. Good job again. LCC cost, you said you brought it down by 27%.
12.74%. Actually, it is in the PPT.
12.74.
Yes.
Okay. So that means LCC, you brought it down, and then at which year will it start, giving profits?
30 years.
30 years. After 30 years, it's going to show.
Yes. 30, 30.
30, okay. No problem. Anyway, this is not something very, even I'm not very sure how to do. You cannot be experts in everything, it's fine. So again, overall, I was very impressed with your work. So congratulations.
Thank you, sir.
Okay.
And thank you, Team Sugriya. We will be taking a small 15 minutes tea break before we begin with the third team. Tea will be served right up and be with us to support the upcoming teams. Welcome back to the presentations for the single family housing division. Our third presentation is from Team Swayam. They have worked on a project, Udachan Mansion, for a single family in Basva Kalyan, Karnataka. The project partner is Vishwa Udachan. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentation. After that, we will have a 10 minutes for a Q&A session. Please keep your answers direct and to the point. Okay, team, the stage is yours. All the best. Yeah, your time starts now.
And our project, Udachan Mansion, is for our is single-family housing for our project partner, Vishwa Udachan. So the design caters to 7 users, and the design requirement for us was to build a single-family housing with an attached studio or an office. So this attached studio and an office is is separated from the rest of the facility. And the site is in Basva Kalyan, in the Bidar district of Karnataka. It's a hot and dry climate.
Good morning. So coming to the context analysis, as it was already mentioned, Basva Kalyan is in the Bidar district of Karnataka, which is a hot and dry climatic zone. The region has the rising temperatures up to 45 degrees, and the humidity drops to at least 20% in the summer. So we're looking at a cultural layer of Basva Kalyan as well, as this was a part of our client's requirement. So Basva Kalyan offers a very interesting and wonderful cultural layer. It's a very well-known cultural site in Karnataka. It has many small temples and little forts and things like that dotted along the urban landscape. Now, looking at our site context, we have the Triptanka Lake towards the north, which sort of regulates the climatic zone and also helps the ventilation in our site surrounding. Coming to our site, the longer facade is oriented towards the northwest, considering the solar radiation and also the views and the ventilation. The site is connected by a national highway to the larger town of Basva Kalyan. So I'm going to talk about the form analysis as well. So we started out as an initial form, but we wanted to bring in a seamless interaction between the open space and the closed space. So there was a play between the volume, and that's how we evolved our form with our courtyards and things like that. Our initial proposal, which was first seen in the initial reports, had a dome and a central courtyard. But considering our cost requirement and our other parts that we'll be discussing further, our final proposal came to be a little bit different. So we'll be explaining that further. Yeah, coming to the architectural design, considering our client's requirement of a cultural layer, we've sort of integrated open spaces which also act as social interaction spaces. So things like a sit-out, a open courtyard, and the front steps, also known as a katte, sort of enforce that social interaction. So our design is basically divided into 2 simple components. We have the private space, which is the house, and the semi-public space, which is the office. So we have that seamless connection between the two with an open courtyard. So our most used space in the house, such as the kitchen and the dining, are located towards the northwestern side, and our office is pushed towards the eastern side. We've also considered the sun path, as Basva Kalyan is a hot and dry zone, so the sun is a very important factor. So we've pushed our courtyard and our punches are located to allow in the natural daylight. So integrating daylight into our design is a very important part. So our courtyard is a U-shaped courtyard surrounded by high walls. So it's mostly shaded throughout the day, which excludes the need of an excessive shajja or another roofing system. So helping us in our cost requirement. Yeah, coming to our section, we wanted to indicate the sinking of the plinth over here to add in the cooler spaces into the kitchen and the living and the dining, because it's the most used spaces in the house. So in our renders, you can also see that according to our cultural context, we wanted to bring in the traditional and modern aesthetics into the design, which provides us a simple material palette, which helps us to put our design in the context. Yeah, here we've sort of mentioned the key components of our design. So we have mentioned our locally available laterite blocks for the outer walls. and our traditional southern courtyard. We have our jali walls here for light and ventilation, and the traditional Mangalore tiles. So innovation. Before we get into innovation, it was very important for us as a team to understand the thermal performance of roof components in a hot and dry climatic zone, because the roof is one of the main spaces for heat acquisition, and this helps determine the ambient temperature inside the house. So we also wanted to integrate a traditional Indian architecture into this innovation. So we sort of figured this out with use of mud rolls. So a mud roll is designed with a combination with the country tiles. So the main criteria for material innovation here was to reduce the density of a mud roll. And this is done by adding rice straw fly ash into the mud roll mixture, which reduces the density by 50%. And the temperature difference between the outside of the roof and the interior of the roof comes up to about 13 degrees Celsius. Now, coming to our rat trap bonds, which is used by CSEB blocks, rat trap bond is a simple arrangement which provides a cavity in the center. So what we wanted to innovate here was to add locally available straw and hay into this cavity, which increases the time lag and also the depth of the wall. So an innovation in terms of ventilation, we wanted to put that into our office because it's the space which has the most footfall. So here we had a combination of a solar chimney and a ground-coupled heat exchanger. Solar chimney as a passive solar cooling devices that uses a vent for the circulation of air. A ground-coupled heat exchanger is a very interesting device. It uses the Earth's subterranean temperature to cool down the air and pushes it into the residential use. So what we have done is we provide a suction pump outside the office, which takes in the fresh air, cools it down, and provides it to the office space, which is then pushed out by the solar chimney. So in a way, creating an efficient ventilation loop inside the office. So that was what we wanted to attempt here. Coming to resilience, considering our location is very important for us to deal with four important aspects with our regards to resilience. The first one is obviously water, considering our hot and dry climate. So dual flush toilets and low flow fixtures were added into the design. And also we have added 3 recharge pits to replenish the groundwater. Considering our location of the site in regards to the wider city of Basava Kalyan, we've also mentioned the local medical facilities nearby so that they can be alerted if there's ever a need. Under energy, from the beginning and the planning strategy, we've also added active and passive energy methods into our design. And obviously, as is an abundance of sunlight found in our site, solar energy is the driving force behind our energy. So coming to drought, which is again related to water scarcity, we have our water conservation and water reuse methods were integrated from the very beginning. So yeah.
Moving on to engineering and operations. We have developed our design in such a way that we have used local materials, integrating local labor to ensure cost efficiency and embodied carbon. The exterior walls are made of rat trap bound walls and laterite walls, whereas the interior walls are made up of agrocrete blocks. Here, it's a simulation we ran to find out the best shading device. This window is of height 600 mm with 4 fins of 350 mm each. It proved efficient as solar heat coefficient was of 0.33. We have used light shelf in kitchen and office areas to increase daylighting. The rat trap bond walls with straw have proved thermally efficient in thermal insulation. These Mangalore tiles and mud rolls as roofing helped decrease our U value, as it's only 5.53 watts per Kelvin meter square, whereas conventional roofing, the RCC plus white mosaic would have been 10.59 watt per Kelvin meter square. Here in the structural system, shear wall system we have used, the vertical walls helps to defend lateral forces and provide strength to the building. The pad footing is our foundation system. Compared to the conventional foundation system, it's much better because it provides a large base area to bear the load of the building. It's easier for construction, and the pad footing advantage is that it can be customized to any building design or soil considerations. Coming to health and well-being, we have used vetiver curtains to the windows to prevent insects, and also it acts as a coolant during the wind flow. The use of jolly walls. The jolly walls are in the courtyard and library. So these provide a very calming visual atmosphere. The use of indoor plants like tulsi, aloe vera, and Boston fir help in retaining moisture of the air and purifying toxins from the air.
So coming to our energy performance, so as per ECBC's code that, energy performance EPI index of a building in a hot and dry climate would essentially be 40 kilowatt hour per meter square. We have achieved an EPI of 20.18 kilowatt hour per meter square, which is about 49.55% of our proposed EPI. So as you can see, so after calculating the total load after a diversity of 45%, we've been able to achieve 4,000 kilowatt hours, which is a significant reduction from our initial case of 8,000 kilowatt hours. So the way we've done this is by using various significant construction methods and techniques. So we've tried to incorporate natural ventilation by increasing the amount of windows and window openings. And since it's a hot and dry climate, it would essentially require a HVAC system to maintain it cool. But as our client required that we propose a naturally ventilated design, we have incorporated this into our design. In addition to this, we have made our microclimate much more comfortable by introducing the courtyard spaces. So as you can see in the radiation analysis, our courtyard space is located to the southern part of the building. So during the summer months, it keeps the courtyard space cool. So you can access this courtyard space during the summer months and reduce the load within the building. And during the winter months, when you would require a little heating, you can again access the courtyard space, which reduces the amount of load that you have within the inside of the building. In addition to this, we have also incorporated various techniques and alternative building techniques and materials in our building envelope design, where we have introduced perforated facades, which help in reducing the solar glare. And also, we've tried to incorporate materials with a lower U value, which help increase the thermal lag that we have, and also reduce the amount of heat gain through radiation. And in addition to that, looking at the windrows diagram and the natural ventilation that the site provides, we have incorporated our building spaces, which is our bedroom spaces, to the southwest corner, which helps increase the amount of natural ventilation going through this area. Next slide. So the energy generation. So as you can see, it's a hot and dry climate which receives a lot of solar radiation and solar lighting. So as per that graph, you can see that the months of June, July, and August have a lower generation as compared to the other months, because this is the monsoon months when we have a high overcast in the area. So as the rest of the months, the sun is towards the southern side of the building, as our building is in the northern hemisphere. We have oriented our solar panels to the southern facing facade at an angle of 17 degrees. And we have placed this on our mud roofs and Mangalore tiles roofing, so that so we have not used the use of stilts as well, which has reduced our cost and our embodied carbon. So the type of panel that we've used is, we've used 16 panels at 22% efficiency with an inverter of 3,500 watt efficiency at 80%, and the battery is 8 batteries at 150 ampere hour. So our total output power at peak, we have been able to achieve 4,000 kilowatt hours. So embodied carbon, which is a very strong point, what we have achieved is we've achieved an embodied carbon of negative 287 kg CO2e, which is a reduction of 114.5% of emissions from a baseline case. And the way we've achieved this is by the sort of products we have used and the sort of construction techniques that we have used. So in terms of products that we have used, the raw materials that we have sourced is through recycled timber, which essentially has a lower and a negative embodied carbon. And we have also used local materials, which reduces the amount of carbon that we have during transportation. We have also used CSEB blocks, which has 52% lesser emissions than the mainstream kiln-fired blocks, as these are compressed and pressed blocks. So the construction process is we have used rat wrap bonds, which uses 25% less brick and 40% less mortar than a conventional construction would. And we have also used lesser RCC framework as by reducing the amount of spans that we have. So using shorter spans and shorter circulation spaces. Next slide. So the amount by which we have reduced the emissions is 11% in our walls, 11 kg CO2e in our walls, 11 in the floor, 278 in our roof system, and 1,900 in our window system, which is where we have used the recycled timber. As you can see from the graph that we have achieved the negative carbon content there. Next slide. So the total difference of the carbon emissions that we have achieved as opposed to the proposed case and the baseline case is 2,259 kg CO2e. Yeah.
So coming to our water efficiency, just a quick background now. We are in a very hot and dry climate, and we have water scarcity in the area. So even with all these factors, we have been able to achieve a water efficiency of about 22%. So this was primarily through 4 different techniques. So one was through the use of mulch basins and permeable pavers, which helped us increase the groundwater, which helps us recharge the groundwater. And the second is through the conserving rainwater harvested in barrels. So initially, we tried doing a cost analysis of rainwater harvesting with proper RCC tanks, but that wasn't justifiable through cost because it doesn't really receive a lot of rain in the area. So in this case, we used barrels. So, and the next technique is the installation of low flow water conserving fixtures and dual flush toilets. And the last one is the use of grey water for non-potable uses. Initially, in deliverable 1, we had outlined our total water usage per day to be 720 liters. And after the use of all the techniques that I previously mentioned, our new water consumption per day is 567 liters. So this is almost 22% reduction in the total water consumption, which comes to around 57,000 liters per year. That's how much we're saving. So you can see here in these how we are saving in different categories. So previously that was a baseline case, and this is the proposed case. So this helps us. We changed the kind of grey water treatment plant that we're using, which initially gave us 35% water savings, and this one gives us 55% water savings. So yes. So the new technique that we are using is a biofilm septic tank. It's a type of grey water treatment plant that uses microbes to decompose organic matter in wastewater. So the process starts with the wastewater flowing in the tank. The process starts with the wastewater flowing in the tank, which separates the sediment from the heavy sediments and the light sediments. And then the microbes present in the plastic intermediaries kind of feed off the waste and clean the impurities. Coming to cost analysis. So another one of our major constraints was our cost. So we had 75 lakhs, which was our total budget given to us. And in the 75 lakhs, we had to do a lot of cost savings. So with this, we have been able to achieve about 10.2% reduction from the baseline value in CAPEX and about 60% reduction in OPEX. So the primary cost reduction that's happening in CAPEX is due to the use of vernacular and local building materials like laterite and CSEB. So in this case, we are using, through the use of these materials, we are reducing the use of RCC, which means I'm effectively reducing the use of steel, which is a major contributor for cost in the construction industry. So that way we are kind of reducing, cutting down cost. And the second thing is laterite. So the size of the laterite block is bigger than that of CSEB bigger than that of CSEB, which means I can fill the same area faster, reducing my labor cost. So the per square feet cost of in the baseline estimate amounted to about 1,570 rupees per square feet. And in the proposed estimate, it amounted to about 1,410 rupees per square feet. So in operational cost, analyzed through electricity, we have, through the installation of 16 panels, we have been able to reduce our electricity bill. And the reason this was reduced to this degree was through the optimized use of daylighting value, optimized daylight, which helped us reduce about 5.6% of our total lighting. Then the next is through energy saving appliances like energy saving appliances, which are generally costly, but overall it helps us reduce our total load and thereby the cost as well. And so our total capex value that we calculated for the entire life cycle for the solar panels amounted to about 9.2 lakhs. And the electricity bill for the entire life cycle again amounted to about 21 lakhs. So this is in consideration of about 7.2% increase for the next 25 years, because the cost is not always going to be constant. We got to account for, we have to account for an increase. So including that, this is our increase in cost. So our return on investment based on this is something we'll achieve in the 10th year. So from there on, our total cost reduction is about 17 lakhs. Yes. So summing up our entire design, with a limited housing area and a very strict budget, we have been able to achieve all our goals in a very satisfactory manner. So we have, in a place that typically uses a HVAC system, we have been able to completely use a naturally cooling system, and our EPI has come to about 20.18 kilowatt hours. And in terms of water, in a very water-scarce region, we have still been able to achieve a water efficiency of about 22%. Our OPEX value has reduced by 60%, and our CAPEX value has reduced by 10%. And for architectural design, we have been able to achieve our clients' demands satisfactorily.
Thank you.
Thank you, ma'am.
You have delivered really well. Now let's hear the jury comments and take questions from them.
I can say it's a well-made movie. The presentation came from all of you simultaneously. That's a winning relay team, I can say. Fantastically presented, and also good round of applause for all of them, the way they presented. The flow was good, and also I am from Karnataka. I know I visited recently Bidar, so you are using laterite and all that. That's a very innovative technique. It will bring down coolness to the building compared to the concrete blocks. Overall, the value proposition is very good in terms of energy calculations, water reduction. It's a water scarce area. So all the points have been addressed at your level, being students, very, very neatly and in a commendable manner. So I don't have any question to ask. Thank you.
Very good job. Great energy, and you also, I think you had your notes, but you were speaking very effortlessly, and that's commendable. It kind of shows how much preparation and thought you've put into your presentation. I loved your slides. It was clean, no clutter, and you had the important things that you wanted to talk about. So really well done in the presentation. So a few questions I have. I was hoping to see more detail on energy performance. You did go very fast, I thought. Still, you ran out of time. Yeah, so good job in exploring embodied carbon. Could you explain what exactly is recycled timber?
So when we were addressing the sort of timber that we wanted to use, so recycled timber is one which you take in from buildings that have already been demolished. So when you're processing timber, initially you have a lot of lumbering carbon that goes into it. Probably when you're treating the timber itself, and you're also trying to source the timber from other places. So that's how we used our recycled timber.
So you're saying you're salvaging timber from existing buildings?
Yes. So these are, when you're sourcing a new timber, you have timber that has been, like you're cutting down your trees and working with that. But these recycled timbers essentially sequester carbon is the entire idea that we studied and got it.
So that's salvaging and not exactly recycling.
Okay.
And so,
yes. Okay. Yes, sir.
Windows.
Right.
You are not making any new design and alteration. You
Yes.
do the same thing in the new building.
Yes, sir. Yes.
Maybe through painting and proper treatment.
Right. Yes, sir.
so if that's the idea,
Yeah.
so have you assessed the feasibility of this for your project if you're going to get the same dimensions that you want for your project? Is that something feasible?
No. So I think we tweaked our project to be, to work with the timber sizes. I mean, the existing sizes that we got.
So I thought as an idea it was good, but it didn't get resolved to enough level of detail
Right.
for you
Yes,
to
ma'am.
come up with embodied energy numbers, because that's the thing that's getting into the negative.
Yes, yes, ma'am.
So that looks like a game changer thing, but
Yes.
it's not resolved, to the level that
Right.
it should be.
Yes.
Because if you are changing, then it should then reflect in your elevations and so on, right?
Yes.
So sometimes, if you're not sure, then keep it at that.
Okay.
Don't add numbers because you
Okay.
need to show something,
Okay.
right? So
Yes.
that's not a great practice. Then my next question was, you showed light shelves in kitchen,
Yes, ma'am.
and it's on west facade.
Yes, ma'am. So we've we've placed our light shelves at a higher level than a lower level, because as if you would place it at a lower level, obviously you would face a lot of glare that would come into the place itself. So what we've done is we've placed
So
it.
question
at-
is, does it work on the west facade? Did you check?
we did. Yes, ma'am.
And so your daylight level improved?
It did, ma'am. Actually, it did. So we have, I think we've shown it in one of our deliverables. I think D2, we've shown that it has sort of improved and added to the sort of daylight we have there.
You might want to recheck
Recheck
this,
Yes, ma'am.
because you need higher altitude, like
Yeah.
steeper angles, and
Yeah.
you don't get that on the west.
Okay.
You get it on the south.
South or north.
So that you will need to relook that, right? And lastly, you talked about laterite,
Yes.
but you also said something called agrocrete walls.
Yes.
Are they the
So-
same thing?
No, ma'am. So we have used 3 different materials. So one is the CSCB blocks. We have used laterite. In addition to that, we have used agrocrete as well. So agrocrete doesn't really take
Are
up
these
loads.
all for walls?
Yes, these are all for walls. So agrocrete was for the non-load bearing walls, and whereas the laterite was for the load bearing walls. So agrocrete is a vegetal concrete that has been brought into play now, where they're trying to discover what it works. So they have included a mineral binder which works with crop residues, which helps binding it with the crop, and then it helps keep away the carbon that you have. So the whole idea is that as a crop, they during the life cycle of the crop, whatever carbon it would have taken in, mineral binder helps keeping it in. So the mineral binder that they have used helps reduce, has a lesser carbon content, about 5 to 8% lesser than what general concrete does. So yeah, we had one reference, which is Green Jams, which offers this material.
So you have load-bearing walls, you have
Yes.
non-load-bearing
Yes.
walls, and they are all of different sizes,
Yes.
right?
But
Block sizes are different.
yeah, but since we're using rat-wrap bond, they almost seem the same. So most of our load-bearing walls are just our partition walls inside.
So it's not very convincing.
Okay.
It's good to substantiate this with more details,
Okay.
right? Than just say we're just,
Right.
laterite is bigger and so it gives us better carbon reduction. So that's, very conceptual,
Right.
right? Because all these blocks of material, they are all of different, the block sizes might be different.
Huh.
So you want to express that in your presentation as well.
Right.
Yeah.
Yes. Got it.
Okay.
Okay, very well presented and very clear. Huh? So, congratulations to the whole team.
Thank you, sir.
You also taken cultural context into consideration. Very good. Huh? Many people forget that. In terms of Sunpat diagram, I see most everyone does the same thing. They show one line only, one curve. Is that the way the sun moves throughout the year?
No.
So which one have you shown?
We've shown the stereographic projection as well in one of the simulations.
Yeah. So the one in the plan that you show is what? For which month or season?
I think the sun.
Right, okay.
We
No
wanted to-
problem. So what you need to do is you have to show the sunpat diagram both for summer season and winter season. Huh? Sometimes you find that in summers the sun is entirely in the north, and that might be true of Basav Kalyana. And that's when you want the least sun solar heat gain ना north से होगा. तो just check that. This is true for all the teams. Huh? Sunpath is very, very important to understand that. Your use of materials, very good. Laterite, rat trap, and agrocrete. Huh? Okay, very good. Yeah, it looks wonderful. And if it's a local material, yeah. Yeah. So one question will be what, like you are using laterite also and you are using rat trap also. So where would you use the rat trap bond and where would you use the laterite? And what is the difference?
Sir, we don't use the rat trap bond for the laterite blocks. Our CACB blocks are laid in the rat trap bond, and we mentioned our straws are added into the whole in our innovation. So that's what we would.
So in which areas would you do that, and why not use laterite throughout the building?
One of our clients' requirements was not to have laterite everywhere because laterite is difficult to maintain is what he told. So that's the reason we have not been able to use laterite everywhere. And brick wall is also a preferred aesthetic for, with our client. So that's the reason we have a lot of brick walls, exposed brick walls.
Okay, fair. Okay. Mud rolls that you used in the roof and it brings down the temperature by how much?
13.
Very good. Excellent. And you can cite a case study where it has been used? Good. So you should show that in your slide. Good. And ground coupling you showed. Now ground coupling, you said that 15 degrees centigrade it comes down to at the inlet level.
Sir, that was the mud rolls with the ground coupled heat exchanger. We were just talking about the conceptual about.
Okay.
Yeah.
So you have to see the length of the pipe in that
Yes.
case. So that becomes very important.
Okay.
It takes a long pipe length to reduce the temperature. So you cannot directly use it. You can show only 6 meters, but sometimes it goes to 80 meters. So thoda you have to be careful about that. In terms of resilience, very good. Shading and light shelf also you've used, and you've shown some simulation for that. Again, very good. Energy generation, you showed 4,000 kilowatt hours you are generating. That is per day or annual?
Yes, sir.
Okay. And your annual requirement is how much of energy?
4,029.
So,
We are almost.
okay, so that you can emphasize that it has become net zero now because of using renewable.
Yes, sir.
Your embodied energy, negative, you've gone very good again. Water consumption, some number are in question. It's a hot and dry region, and means availability of water is low. So how can you have a consumption of 567 liters per day per person?
So it's not just consumption that we are, okay, so our low flush toilet systems and the water efficient fixtures, we quantified all of that. Go to slide 19.
Right. So you went from 720 liters per day to 567, right?
Yes, sir.
In Mumbai, we use 135 liters per day per person, even though we have a lot of water. So probably you need to look at your number.
Okay, okay.
Whether 720 liters per day per person is right or not.
Okay. Okay.
It might be overestimated. So if you compare that.
720 was according to bylaws, so 135 liters per person per day. That. And then 567 was our proposed value.
That is for the family.
For the whole family.
Okay.
Yeah. No, family of 7.
Family of 7. So
Yes.
you generally give that liters per day No, it's fair, ना चलेगा. But generally per person देते हैं ना. हाँ. Okay, fine. Fair. Then it's okay. ठीक है. Even you. हाँ. हाँ. Okay. Okay. So you've also looked at the construction cost and you've made a reduction, very good. And your renewable energy becomes free from 10th year onwards, again very good, and you summarized it very well. So once again, congratulations on your presentation. Good work. Okay.
So we'll start with the last presentation. Our fourth and final presentation is from Team Zenith. They have worked on a project, Sukhadam Phase 2 in Anand, Gujarat. Their project partner is Radhaswamy Construction. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to end the presentation. After that, we'll have 10 minutes for a Q&A session. Please keep your answers direct and to the point. Okay, the stage is yours. All the best. Your time starts now.
Good afternoon. Good afternoon, respected jury members. We are Team Zenith from Single Family Housing. What do you expect from a habitat? Or what should a habitat be? It should be a place where people comfortably respite in nature. It should be a place where nature should be used in its full glory. They cherish life, they value the spaces, they value themselves. The habitat is a therapy in itself. It sits in harmony with the natural environment, ensuring people, places, projects, and planet to become one through a habitat system. Now, taking inspiration from all the above mentioned, we have come up with a solution which is very technically, emotionally, and inspirationally apt. Now, let us look at the solution. Our site lies in the northern fringes of the Anand city in the region Charotar, which means naturally abundant area. Anand has a hot and dry climate. The user group is that of upper middle class and high income group. Now, the 10 contests of Solar Decathlon India could be addressed through just one traditional science of well-being and harmony with nature, that is Panch Mahabhut, which lays stress on the coherence of the natural and the human-made systems, which are basically knit together in 5 basic elements of existence. And the first, so the center of philosophy could be addressed, and we can also, since the 6 of the 10 contests could be addressed directly by these elements, the rest 4 could be addressed by an amalgamation of these 4 elements. The first element being
taking inspiration from this, let us take the first element, the fire. Fire represents heat, light, metabolism, energy, and power of transmission. Fire also takes care of the energy performance and health and well-being context. Next. So through climate analysis, we can determine how to cherish the sun and invite light into our home. Next. After analyzing, we have oriented building at 33 degrees northwest to avoid perpendicular incident radiation. The ergonometric study helps to reduce the workload of the occupant, and which results into less metabolic heat generation. Next. So coming on to the energy performance, the first element of the building assembly is the wall. The overall U value of the wall is reduced to 0.7 watt per meter square Kelvin by using flash bricks and red trap bond. Through micro shading, the Christophorus pattern, we have achieved the micro shading, which also results in the better thermal comfort. The WWR is kept at 15.1%, which increases the thermal conductivity. Mutual shading and trees also enhances the comfort conditions. Vegetation and earth insulation mitigates the heat. Now, our site lies near the Tropic of Cancer, so the roof heat gain is a major concern. So through shading of solar panel, vegetation, then through hydroponics and terrace gardening, and lastly, the filler slab, we are achieving that. The second element is the roof. So by using sandwich filler slab technique, the U value reduced from 1.4 to 1.2 watt per meter square Kelvin. Thirdly, the windows. The SHGC of glazing of all windows is 0.4, and the windows will be operating manually or through sensors as per the climate. Now, as I said, as per the sensors, we have integrated the smart solutions. So sensors will be installed in all the parts of the building, which will give the insights and raise the awareness through models like lux meter, thermal comfort, visual comfort. Now, coming on to the next slide, the sensors detect the light quality according to the matrix. We have a demo here. So appliance optimization has been taken care by using the BEE rated 5-star appliances, which also consumes the less energy compared to the normal appliances. The artificial light optimization has been simulated through light power density. So we have calculated the interior LPD is 1.9 watt per meter square. Those for exterior LPD is 0.5 watt per meter square. The electrical consumption as compared to the normal house, we have reduced it 10.8% by applying all these strategies. The daylight optimization has been simulated through UDI, ASE, and SDA. The appropriate range for UDI should be between 40 and 60 at a 90% threshold. So our calculated is 56.63%. SDA, the range should be that the 300 lux should be for more than 50% of operating hours. Overall score, our calculations comes to around 54%. ASE, the norms is 3%, while our score, estimated score comes to around 2.89%. Light does not only solve the purpose of seeing, but it is also connected with the bodily systems. So proper amount of light ensures the healthy mental health, healthy skin condition, and circadian cycle. We are harnessing solar energy both way in the building, actively and passively. The active way is through solar panels, and the passive way is through solar chimney and earth air tunnels. So the heat of sun has been used to bring to run the solar chimney, and it is connected with the earth air tunnel, which brings much needed vitality through fresh and pre-cooled air. The simulations have been performed after applying all of the strategies, and we have taken care of that. The windows would be of the mixed mode ventilation. So for user will have air conditioning system, how they see fit it. So being a residential typology, user will be feel incentivized to conserve the energy and reduce the total electricity bills. For API calculation, we have taken a base case of a normal house that is 49.31 kilowatt per square meter. But by orienting building in proper direction, through shading, by using appropriate properties of materials, earth insulation, controlling aperture sizes, through landscaping, and lastly, the combination of solar chimney and earth air tunnel, we are able to reduce EPI by 60%. So the proposed EPI design comes to 19.46 kilowatt hour per square meter.
So the next element is air. Air comprises embodied carbon, indoor air quality, and health and well-being. As we all know, air becomes contaminated when CO2 content increases and the O2 content decreases. VOCs, such as formaldehyde and benzenes, also contaminate the air. Health aspects, such as chronic bronchitis and bronchial asthma, are also happen due to the contaminated air. Now we see what are the strategies we have used to control to have better indoor air quality. So fresh air ventilation and the cross ventilation are according to the IGBC baseline criteria. You can see in this table also. Sensor-based openings take the live feedback about the air quality and thermal condition to operate accordingly. Air becomes so the combination of earth air tunnel and the solar chimney. Earth air tunnel flow the cool air to these spaces by rejecting heat to the ground, and the stack ventilation will flow the hot air through the stack, and the solar chimney will flow the hot air through the stack ventilation. So humidity will be controlled by the two factors. First, the lime plaster. So lime plaster absorbs CO2 and emits O2 by the process of carbonation and the dehumidifier plants. So indoor plants. So indoor plants also helps in improving the indoor air quality. Like Gerbera daisy absorbs CO2 and benzene. We have also done a field test by using indoor air quality, by using the indoor plants to achieve better indoor air quality and the CO2 level, and we get the positive results. The building operates as the living organism prioritizing health and well-being. Sensor-generated data for actions based on user needs. Manual or smart devices control optimizes energy consumption for optimal living conditions. Now the embodied carbon. So materials which we have used in our design are locally available and are in the 500-kilometer radius from its manufacturing to its retail. We have also made a scorecard to see and to compare which is the best possible material in our design. So, so we have also used filler slab instead of using the conventional RCC slab. Since filler slab consumes less material than a conventional RCC slab, hence less embodied carbon energy will be released. So the next element is water. We are embracing 4 R's of the nature for the better water performance. That is reduce, recharge, refresh, and the recycle. So let's talk about the water cycle. By rainwater harvesting, the rainwater is collected and then it is passed through the medicinal plants to the borewell recharge. And after the RO and the TDS checking, it is divided into potable and the non-potable water. And then it is sent to the grey water treatment. After that, it is ultimately used for the landscaping and the flushing purposes. So first R is reduce. We have reduced the water consumption by using water-efficient fixtures. The average daily water consumption per capita per day per person is 135 liter. But by using water-efficient fixtures, we have reduced up to 63 liter per capita per day. The percentage, as you can see in the table, the total percentage saving by using the water-efficient fixtures is 49%, which we have achieved. Now, the recharge and the refresh. So, rainwater collected will pass through the first rain separator and then to the aromatic and the medicinal plant, which adds quality in it. And after the primary filtration, it will direct it to the borewell recharge. So the groundwater recharge potential yearly of our site is 121.879 meter cube. And number of days harvested water can be used is 398 days. Hence, our site could harvest rainwater for more number of days than required. Our area has fairly groundwater level, which is available for disposal and consumption. So hence, investment of storage capacities is burden on costing. So next is the grey water treatment and the recycle. So third is to reduce consumption of potable water and wastewater generation is used for flushing and the gardening purposes. So first rainwater goes to the settling tank where the solid waste is settled down. And after the flow equalization tank, it will move to the wetland cell where the wetland plants will absorb microorganisms. After the level adjustment basin, it is ultimately moved to the drip irrigation. So daily water consumption of a 6-member family is 378 liters, from which 306 liter will be getted from rainwater and the 72 liter will be getted from the grey water. The remaining grey water, the recycled grey water will be then sent to do the gardening purposes. So now, the superior plumbing. The energy needed to pump the water through society's plumbing can be captured and put to a good use by replacing ordinary pipes with a network of pipes that contain turbines and that produce power. This energy will be used for lighting the streets.
After addressing fire, air, water, and 5 contests, let's move to the 4th element of Panch Mahabhut, earth, and the 6th contest, that is health and well-being addressed through landscape. Bringing nature to build. As one can observe, the tall trees having large foliage are planted on the southern and the western side to avoid heat radiations. Creepers are planted on the north and the east side. 50% of the paved area is shaded by trees, which reduces the UHI by 20%. 100% native and all seasonal plants are grown, which provides a therapeutic effect. Various mosquito repellent plants are used, which not only repel mosquitoes, but also attracts pollinators. southern winds flowing through the flowering plants that are planted on the southern side directly moves into the dining area. We have incorporated square foot farming along with crop rotation. So basically, square foot farming is a space efficient method wherein the plants are grown by benefiting mutually each other. We have also incorporated drip irrigation system. Vermicomposting is done on site, which helps in replenishing the earth's nutrients without much of human interaction. Also, social and environmental integration and interaction are maintained through green spaces and spill-out spaces, which have low maintenance and medicinal plants that are maintained by the gardener. So basically, it is a closed loop system wherein the residents will be segregating the organic waste in order to get the organic vegetables from the gardener in return, while the gardener will be selling the produce in order to get profit or an incentive, which basically benefits the environment with luscious and green trees.
So, all the discussed 4 elements will help us to achieve better thermal comfort. Now, so in radiant temperature, building envelope, micro-shading, better orientation and shading devices for air temperature and the movement of speed, earth insulation, sensor-based opening, earth air tunnel and the solar chimney. For humidity control, lime plaster and the dehumidifier plants. And for the metabolic heat generation, ergonomic design is used.
While following the basic principles of Vastu Shastra, our design acts as a confluence of traditional value of the past with the promise of the future. The 4 BHK is not only space and resource efficient, but is also especially efficient considering the ergonometric and anthropometry. As one can see, the living room holds the semi-formal and informal gathering. The kitchen and the dining space acts as a visual connection while maintaining the privacy. The ground floor bedroom is made for the elderly people to ease the movement. As we move up, a gathering space has been provided which incorporates the interaction between the family members. Next. As one can see this cutout, this is basically done to enhance 2 features. One is the light well, and the other one, it cherishes the elements of water. As when it rains, the water drops down. While we have kept in mind the elements of Panch Mahabhuta, we have also incorporated the elements of biophilia and sensory-based design by maintaining an interaction between the inside and the outside world through gentle thresholds. All these 4 elements could be seamlessly binded together by the 5th element in a cohesive and symbiotic relation. And this harmonious cooperation is a cherishable environment what we are looking for.
Now I will be addressing the remaining 4 contexts. Innovation for us is effective and efficient yesterday, and to address this, we have designed the passive design strategies, traditional passive design strategies like solar chimneys and earth air tunnel combo, which draws a cool air, along with futuristic technologies like sensor-based. So first is earth air tunnel and a solar chimney combo, which draws a cool air, creates a 8 to 10 degrees Celsius of temperature difference from the outside temperature. Second is the filler slab. We have introduced innovation in the filler slab. What we have done, if we cut a section, 2 clay tiles are used, in between 10 mm air gap is provided, which reduces the embodied energy up to 33% and reduces the temperature up to 5 degrees Celsius. Third is insulation, earth insulation. We have incorporated insulation to reduce the EPI. Last but not the least is red trap bond. By providing this, 55% of U value can be reduced as per the as compared to the conventional wall. While designing the structure, carbon emission has been taken care of. We have designed a composite structure, frame and a load bearing. Frame has been incorporated separately for staircases and a water tank, and rest are load bearing. We have designed in accordance with the IS 456 codal provision. We have designed structure in StatPro software to ensure the wind load, seismic load, and soil bearing capacity of Anand. We have used PPC cement, Portland Pozzolana cement, which contains a fly ash in it, which reduces the carbon emission. And of course, a FE500 steel reinforcement is used. Next. In case of resilience, we have encountered 3 major risks at our site. What we have done is we have incorporated risk like earthquake, prone to flood, and hygiene. As I mentioned in the previous slide, our robust construction will ensure the seismic activities, the structure is safer in terms of seismic activities. In terms of flooding, it can be ensured. And in terms of affordability and economics are our driving principles, which is proportion between resources consumed and value generated. So in terms of quantity, our base case, as compared to base case, our proposed case is 6% higher, which is used in solar chimneys and earth tunnels like traditional methods and active strategies like futuristic technologies like sensor-based, which can be paid off in approximately 7 years as per our calculation. Last but not the least is quality of the human well-being, because it is immeasurable, right? In terms of quality, safety, security, sustainability, and well-being are our driving principles. Apart from that, as our tagline says, living here itself is a therapy.
Thank you.
It's just the concluding slide. Can I just go ahead?
I'm sorry.
That's why just the concluding slide.
Sorry. Yeah. You can maybe answer if you want. You can, like, during the Q&A session, you can continue. Yeah. Thank you. You did a great job.
Thank you.
Yeah, let's hear the jury comments and take questions from them.
Team well explained every point. Really a good, thoughtful design and process. And you are sure of what you are doing. That is the main thing. Other parts have been explained very well in terms of all the 10 parameters. So the time you could not manage. So that is one thing you should. Some details for more. In fact, explanation was not required. You were doing that actually. So overall, like using the blended cement concept, so it's very good actually. That has come out in your presentation, not in any other presentation. Because that's very important. As the architects start specifying blended cements, because that is a major material. Reduction in steel is very important. Apart from that, you have covered all these panchabhutas and all the parameters. Coming from that divine the explanation, it has given more value addition, like the Vastu principles you have followed. All the best to you.
Thank you, sir.
Good job and good effort. You were pretty confident when you were talking, and I like that you didn't read also, and you were speaking, and you put in some effort to prepare for that, like the other 2 teams as well, so good job on that. I liked how you explained your concept, and you didn't jump directly to, this is my house, and so I really liked that you kept that thread till the end, talking about 5 elements. So that was really nice. I also like that you put some effort in understanding, doing some field testing on landscape, how it worked. Clearly you saw that there is a difference. But I would have loved to see that translation into design in terms of, you showed landscape, but something more tangible because you did some testing. So could have been like, you would need X number of plants in this kind of a room, and that would have been a lot nicer to see how your field testing is actually implemented in the design. Something for you to think about, right? You also put in significant effort in assessing embodied carbon, which is also a very good thing. And I also like that you thought about some things on a campus level and some on an individual house. So there was that connect, so which is also good in terms of thinking. Now, just one common thing I want to tell to all the teams, which we saw it was common, passive strategies are not innovation, like rat trap bond and ventilation. Those are first principles, which you will implement anyways to get a good high performance building design. It is which what you do over and beyond this will count as, like the mud roll example was a good concept, or an example of an innovation, we could take that. But you can't say that we have good ventilation as a innovation. So I want to, everybody has done that, and we've given that as a comment even in the reports as well. So something to keep in mind. Now I want to ask you, what was this sensor thing? You came with such preparation. Would you like to show this? Like, we didn't see anything. You just spoke into the phone. Okay. So then, should we like finish all the Q&A and then you show us a demo of it? Maybe we'll do that. How much time we have, Pooja? Okay. Do you want to see this demo? Yeah. So why don't you show it? That's understood. Are you going to show us something? Yeah. Sure. Okay. Sure. Go ahead. This is the last team, so then we can have time to see that as well. Yeah, sure. I want to then ask you, since you have these sensors, you said it's in the windows, it's pretty much in the whole house.
Yes.
Plus you have a earth air tunnel.
Yes.
And then you said there is a 8 to 10 degree delta T you can see. And you've simulated this, but have you checked how high should be the shaft of the solar chimney? I didn't see like a glazed area over there.
Move to the slide of earth air tunnel.
It's a solar chimney or it's just a vent?
It's a solar chimney, which is we have combined with the earth air tunnel this way. So it is, we can also see there in that section.
So the chimney creates the temperature difference, right?
Yes, chimney sucks the heat of the sun. Yes. So the principle of straw.
So do you have glazing on that chimney on top?
No, we are not having glazing on that.
So it is just a vent pulling air,
yes.
Isn't it?
The principle of straw works here. The fresh air will be through earth air tunnel, and then the hot air will be sucked through the solar chimney.
Did you simulate this delta T? Did you see that this is going to, actually flow like this?
Yes.
Okay, because I think it was not very convincing to me, and hence I'm asking. Okay. This is like a, you can so if you want to create like a stack effect, right? Yes. And then because there is all of this diagram that you're showing, and the other way is like you actually put glazing on the top of that solar chimney.
Because at the top of the part, the heat should be more, so that it will suck more hot air.
So you have added?
No, not on the solar chimney. We are having on the other part of it.
Other part meaning?
Yes. See, this will be the open, but on the roof, I will show you in plan. Yes. So this much part we are having glazing, and in between we are having a solar chimney.
So that staircase shaft has glazing, that's what you're saying?
Yes.
Okay, so I'm not too sure that this is going to work. You will need to experiment with the height of that stack above the roof to get the delta T based on all of these, how many vents and all of that. It's true for the other team too. I know this takes effort to actually come to sufficient detail, but then you are showing so much evidence. 8 to 10 degree delta T, thermal comfort, so then we need to then ask that as well. So I'm not too convinced that this is going to work the way you're showing, over here. And what else? I think that is about it. Over to you.
Ma'am, we matched the delta T is the temperature difference from the external. We matched the delta T that it has the earth tunnel will give the ground temperature. Has the difference of delta T, and it matches with the internal temperature. So there is the temperature difference of delta T we have set through this.
Okay. So your ground temperature is about 8 degree lower than outside dry bulb temperature.
And the internal temperature is matched with the ground temperature because of the earth air tunnel will reject heat to the ground.
And it has
So
been
you
kept at the very higher point of the house.
Yeah, so just think for you to think about, if you have this shaft going through your home, and that 3D axos shows that air is going everywhere in all the rooms. You know, that is not too sure. In one of our projects that we worked on, we've had to increase the internal vents a lot more than regular doors and windows in order for this to happen. That going, circulation everywhere. And so that is something you need to think in sufficient detail to then conclude on that. Yes?
Sure, we'll do that.
Okay, team, very good presentation, excellent in fact, and it's a great improvement on your last deliverable. Huh? So, very good. Yeah, really, really commendable work that you have done. Very good passive techniques. You've used sensors, unfortunately. Of course, we can see it now. You've done a lot of calculations also. So again, very good in terms of simulation, renewable energy. You added earth air tunnel and chimney. Your health and well-being section was also good in terms of fresh air and cross ventilation. Lime plaster for humidity control, very good again with use of indoor plants. So you are using traditional techniques also. तो अच्छा है. Very good comparison of materials for embodied carbon. Huh? So again, very commendable work. You've done 49% water consumption reduction, right? Yes. And then you have used rainwater harvesting also, so you become now water positive, is it? Very good. Hmm? And I really liked your scheme for landscaping, including your square foot farming. Is it square foot or it is square meter? Square foot farming. Good work. You also looked at food security and good roof system, and payback period of 7 years is also very good. Huh? So congratulations on a very good report. Huh? And wish you all the best.
Thank you, sir.
You can sit now. We have time, Pooja. Yeah, then you can show. You are a student?
I'm actually an entrepreneur student.
No, you are a student of the institute? You're part of the
I'm student. I'm doing MTech.
Very good.
I'm officials.
What sort of sensors are
These are smart sensors. Sensors have different qualities, right? Sensor like light sensor. See, this is controlling. This is just control, which we are getting through the devices.
No, you told like sensors.
Okay, so light sensor, humidity sensor, CO2 sensors. I think the team has a lot of.
We are also addressing the thermal comfort. So air comfort, visual comfort, thermal comfort could be addressed through this.
can only get information. That's all.
By using the fan. You switch off the fan on the tunnel, so it will push in the extra air whenever there is required. It won't be on all the time. It will be both manually and through sensors.
We were made to completely automated the building.
Yeah, so we told that the building would act like a living audience, like how we work.
Thank you, jury members, and thank you, Team Zenith. Folks, that was our last presentation in the single-family housing division. Our esteemed jury panel has also shown immense dedication for assessing these entries. I want to thank the jury members for your thoughtful assessment and comments. A big round of applause to the jury members. And I want to congratulate all the finalists as well. So a big round of applause to them. As the jury coordinator for this division, I have had the opportunity to see these teams submit their deliverables. They have done some incredible work. Let's not forget that these teams have discovered a way to collaborate and do integrated design during the last 9 months. I think that itself again deserves a big round of applause. This evening, the jury members will meet and decide the winner and runner-up teams. Who will it be? We'll see it in the evening and tomorrow. This year, we have a building industry innovation exhibit where you get to see innovative building products that address climate change. The exhibit is now open for you to visit and look at these innovations. Online folks out there, don't worry about missing out on the exhibit. Stay tuned to our channel at 6 p.m. and watch these exhibitors pitch their products to the Infosys jury panel. Until then, goodbye and have a great afternoon. Thank you.